and curl their outer edges. Into the curl of the ends is injected a rubber gasket material. Graphically illustrated, it looks like this. Later on, when the ends are seamed on the can body, this material will provide an airtight bond between the body and the end pieces. Now to make the can body. This body maker actually operates too fast for us to see how the can body is formed. So after the body blanks, which you saw being cut earlier, are fed into the body maker, we will follow its intricate steps in slow motion and with graphic illustrations. First, the body blanks move to a notching station. Here, small notches are cut from the corners to eliminate a double thickness of metal when the ends are seamed on. The body blank is then formed and hooked into the familiar shape of the can around the body maker. Next, they are bumped to form and tighten the side seam. The formed bodies then pass over fluxing wheels to a hot solder bath, where solder is applied to the outside of the side seam. The side seam is then wiped off and cooled by a blast of air. Then the bodies speed along to where they are flanged at each end, so the tops and bottoms will fit on. Here you will see why the body blanks were notched. The notches eliminate a double thickness of metal where the side seam overlaps the flanged part. Only 2 layers come together at this point, thus permitting a perfect seal when the end pieces are seamed on. Here in the can-making plant, only one of the end pieces is double seamed in place, and the other end left open so the cans may be easily filled at the canneries. This operation is extremely important. It calls for the utmost precision. One end is placed on the can body. It curls over the flange on the body in precisely the right amount. Remember that rubber gasket material in the curl of the end pieces? Well, this material provides a bond between the layers of metal to ensure a permanent, airtight seal as they are pressed together to give us the finished double seam. Later, when the cans have been filled in a cannery, the other end will be double seamed on in the same way with exactly the same precision. But returning to the can making line, our cans with only one end seamed on leave the double seamer ready for final testing. Fresh air is a wonderful thing, but not in a can. By means of air pressure, this machine detects a can that might leak air and tosses it out as a suspect, to be checked separately against a can like the red one we know to be a leaker. And that's it. The seemingly simple can requires such precision in its making that any variation in excess of a few thousandths of an inch are sufficient to cause automatic rejection. This ability to achieve high-speed production with such precision has placed the can manufacturing industry in the front rank of the mass production leaders of the world. But how do all these billions of cans get to the right place at the right time? Food cans, for instance. Well, that takes a lot of planning, a lot of experience and good teamwork between the can manufacturer, the canner, and the farmer. Actually, there's hardly a minute of the day or night that you won't see trucks loaded with containers or freight cars similarly loaded on their way to the canneries scattered across the land.